Hello students. Today we are going to solve linear equations with variables on both sides using manipulatives on the left here with the bars and the squares, as well as showing what it looks like abstractly using algebra. Now before we move on, just a couple of reminders. One, we have here the buttons on the left. Now I would try to avoid the undo button, this reset button, because it will reset everything you did and you don't want to erase everything you did. The first button on top here with the little hand is to move things around and to drag. You'll see just a little bit, drag these little bars and squares down. The second bar is to annotate, so we're going to do that when we actually write here, but also when we're crossing out any pairs that cancel out. So for example, let me write something like this. Then we have the eraser button. You have a small, medium, and large eraser. Let me use the medium, and you can see the size of the eraser you press and drag. You'd want to use that. Like I said here at the bottom, the little arrow to reset, it will remove everything you did. So right now I just did that little thing, but typically if you did a lot, you don't want to erase everything that you did. Okay. So here we have an equation, and an equation has this lovely equal sign, and the equal sign, think of it as a scale that is perfectly balanced, meaning the expression on the left side is equal in amount to the expression on the right side. If it's not equal, if what you have on the left side does not match what you have, is not equal to what you have on the right side, and vice versa, then what you have is not an equal sign, it's a not equal sign. That means that the scale is not balanced. So if you were to think of a scale that is not balanced, one side of the scale is way up there and the other side of the scale is way down there. It's completely unbalanced. Okay, let's erase this. But when you are dealing with an equal sign and we are going with the assumption that this is a true statement, then you're thinking of a perfectly even scale where one side is perfectly even to the other side. No side is tipping to one side or the other. Okay, so what I have here on the left side, now I use my little t-charts. My little t's are going to be really easy so we don't confuse what's on the left side of this equation and what's on the right side of this equation. We make it very clear that there's a distinction between each side. These little things represent, well, first of all, 1x is represented by one green bar. So 3 x's means you have 3 green bars, while 2 x's means I have 2 green bars. And a negative x is represented by a red bar. Now the numbers, the real numbers here, a green little square means the positive 1. So if I have 7 squares, that means I have 7 ones. And when you add 1 7 times, you get the number 7. The red square represents a negative 1. And if I add 5 negative 1s, it's negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. Okay? Now remember, if you add a negative x to x, or x minus x, they give you 0, so they cancel each other out. Same thing with the numbers. 1 minus 1 gives me 0, so they cancel each other out. So think of them next to each other as a cancel pair. So the first step, let me click this button. When you solve an equation, you want to get x by itself on one side. It doesn't matter which side, as long as x is equal to a number or a number is equal to x. As you can see here, that's not where we are at this point. First, you want to undo any addition or subtraction. So first we want to get rid of the numbers that are by themselves. So here to undo -5, I need to add 5. The opposite of subtraction, or a negative number, is addition, or a positive number. So I'm going to add 5. 1, 2, 3, click drag, 4, click drag, 5. But when I do to one side of my balance scale, I have to do it to the other side, otherwise it tips over. So I'm going to bring again 5. 1, positive 1, plus positive 1 is 2, plus positive 1 is 3, plus positive 1 is 4, plus positive 1 is 5. Remember, I am following the rules of equality. Now, before we move on, what have we done here? We've noticed that we have created five pairs that cancel each other out. Because we know -1 plus 1 is 0, -1 plus 1 is 0, and so on. And now we have 3x on the left side and 2x plus, and if we add these together, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this represents 12. But we're not quite done yet. The goal is to get x's, the 1x, and all the numbers on the other side. Now we managed to move all the numbers, just the numbers, not the variables, to the right side. I'll get rid of these x's on the right side. So how do we get rid of the x? Well, we have to undo a positive x by subtracting 1x, and undo the other positive x by subtracting another x. So in essence, I brought down -2x on the right side. But what I do to the one side of the equation, I have to do it to the other side. So I just brought down on the left. So what have we done here? Well, we have created to make this a little bigger. We have canceled, here's this one cancels and this pair cancels. X minus x is 0, x minus x is 0, and these two cancel as well. So now you look on the left side, we have successfully managed to leave just one x equals, and we have successfully managed to get rid of all these x's. So now we counted these already, 12. Okay, let me make this. So now let's do the same thing, notice the same problem, but we're doing it with algebra now, abstractly, one could say. So notice the first thing we did here was we added 5 to both sides. So before I do anything, when I do my t, I'm going to write the left side on the left side here, and then the right expression, I'm going to write it here. So your first step is to just rewrite the problem. So we've replaced the equal sign with just the little t to represent one side of the scale and the other side of the scale. It's just another way to symbolize. Okay, so we have expression 3x minus 5 on the left side of the equation, and then we have the expression 2x plus 7. So first I'm going to do that. Now you saw what we did here. We added 5 to both sides of the equation. So I'm going to go ahead and do that. On the right side here, I'm going to write plus 5. On the right, plus 5 gives me 0, so they cancel out. Now I'm going to go ahead and clean it up a little bit. The line just tells me let's make this x, because we were able to cancel out the -5 by adding 5. Now here I'm not going to add the squares and the bars together, because I don't know the value of the bars, but I do know that I have 12 squares, so I do know that I have 2 bars plus 12 squares. I can combine the numbers, just the numbers. 7 plus 5 is 12. The second thing we did is we saw that we wanted to get rid of these positive 2x's on the right side. So we brought down negative 2x. So 2x minus 2x. But what I do to one side of the equation, I do it to the other side. Let's go ahead and write this here. So 2x minus 2x is gone. So all we have here is 12. And then we had 3 bars. We took away 2 bars. We're down to 1 bar. And the bar is my unknown, my x. Notice I got the exact same answer here. 2 slightly different methods. Now we can do a quick check. I'm going to put I'm going to do a quick check here. On the bar, okay. And how do we do that? Well, let me make this a little bit smaller. This is saying that if x equals 12, then this statement here is true. What's on the left is equal to what's on the right. So the left here, we have 3x minus 5. But now we know what x is. Instead of 3 times x, it's now 3 times 12. Now I'm going to use parentheses as my multiplication symbol, minus 5. Now following PEMDAS, first we are going to multiply. 3 times 12 is 36. So I'm going to replace that by 36 minus 5. And then I can subtract. 36 minus 5 is 31. Now let's take a look at what's on the left side. Excuse me, I just did the left side. On the right side of the equation, 2x plus 7. So again, instead of 2 times x is 2 times 12 plus 7. So first I write down, I'm evaluating to check my answer. So 2 times 12 equals 24. 2 times 12 plus 7, the same thing as 24 plus 7. So now I can add 24 plus 7 is 31. And as you can see, 31 equals 31. That is a true statement. So I solved for x correctly by checking. And how do we check? You evaluate. And evaluate is another word for substituting given a value. So we substituted x with the value that we found earlier.